In this video, I will show you how to expand a binomial like x plus 3 to the 7th power using something called Pascal's triangle. This is AP Precalculus topic 1.11. If you appreciate this content, please show it by hitting that like button. Expanding a binomial in the form a plus b to the n power can be very tedious as the exponent gets bigger. Expanding x plus 3 squared isn't that bad. It's x plus 3 times x plus 3. And we would just do an extended distributive property here. So x times x will be x squared. And then x times 3 is 3x. And then 3 times x is another 3x. And then 3 times 3 is 9. Combining like terms, we have x squared plus 6x plus 9. So that wasn't so bad. But what if we want to expand x plus 3 to the 3rd power? That would be the same as x plus 3 squared times another x plus 3. So first we would have to do what we just did, but then we would have to take another x plus 3 and multiply it times our previous answer. So we could do this by hand by doing the distributive property 6 times. So x times all of this will be x to the 3rd power plus 6x squared. And then x times 9 is 9x. And now I will distribute the 3. So that's going to be plus 3x squared plus 18x and plus 27. Combining like terms, this gives us x to the 3rd power plus 9x squared plus 27x plus 27. Alright, so that was only to the 3rd power, and that was already pretty annoying. So imagine how time-consuming it would be to try to expand x plus 3 to the 7th power. It would be pretty crazy. Instead, we can use Pascal's triangle, which gives us the coefficients of all of the terms in the expanded binomial. Each row corresponds to the degree of the polynomial. Just be careful because this first row is row 0. This gives you the answer to a plus b to the 0 power, and anything to the 0 power is going to be 1. This row gives us the coefficients of a plus b to the 1 power. This gives the coefficients of a plus b squared. And then it's a plus b to the 3rd power, a plus b to the 4th power, and so on. You do not have to memorize Pascal's triangle. Just start with a small triangle of 1, 1, and 1. Notice that Pascal's triangle always has 1s for the first coefficient and the last coefficient. Then all you have to do is add up any two numbers, and that gives you the number in the middle. So I will have a 2 right here, and then 1s on the ends. For the next row, 1 plus 2 is 3, 2 plus 1 is 3, and 1's on the end. I can get the next row. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1's on the end. And you can keep going for as many rows as you need. Here's how you use Pascal's triangle to expand x plus 2 to the 5th power. First, locate the correct row. So this is degree 5, so we're going to use row 5. Remember that the first row is the 0 row. These are the coefficients. So copy down these numbers in order, leaving spaces in between. The coefficients always start off positive, so put pluses in front of all of them. Now look at the first term of the binomial. That is on the left, so it starts off on the left. and it begins with the degree of the binomial. So this starts off x to the 5th power. After that, it decreases for every term. So we will continue with x to the 4th power, and then x to the 3rd power, and then x squared, and then x. And the last term gets no x's. Now look at the second term of the binomial. This term is on the right, so it starts off on the right side of the expanded polynomial. So I'm going to put a 2 right here. Again, we start off with the degree of the binomial. So 2 to the 5th power. And with this term, we go from right to left, decreasing the exponent each time. So this will be 2 to the 5th power, and then 2 to the 4th power, 2 to the 3rd power, 2 squared, and 2 to the 1st power. The last term gets no 2's. For the final answer, all you have to do is simplify. So the first term is just x to the 5th power. But for the next term, we have a little bit of work to do. This is 2 times 5, which is 10. So we have 10 x to the 4th power. Now 2 squared is 4. 4 times 10 is 40. So this term will be 40 x to the 3rd power. For the next term, 2 to the 3rd power is 8. 8 times 10 is 80. So this term will be 80 x squared. 2 to the 4th power is 16, and 16 times 5 is 80. So this term will be 80x. And finally, 2 to the 5th power is 32. So this is your expanded binomial. Now let's expand 2x minus 1 to the 4th power. First, we identify the appropriate row, which is this one. Let's copy down these coefficients with some space in between. So we have this. Next, we take the left term and we put it on the far left, starting with the degree of the binomial. And then we recopy it for each term decreasing the degree. So we will have 2x to the 3rd power, 2x squared, 2x, and then nothing. Now we grab the term on the right, and we put it on the far right side of the expanded polynomial, starting again with the degree of the binomial. And then we work our way from right to left, decreasing the degree each time. So negative 1 to the 3rd power, negative 1 squared, negative 1 to the 1 power, and then negative 1 to the 0 power, which you don't put at all. Be sure to use parentheses like I am. Without parentheses, you would just have 2x to the 4th power here, which would be wrong. With parentheses, this really is 2 to the 4th power, which is 16, and then x to the 4th power, which is totally different. The step I'm about to show now is optional. Some of you can simplify this in your head and go straight to the final answer. But I'm going to use an extra step to apply all of these exponents. So the 2x to the 4th power is going to become 16x to the 4th power. 2 to the 4th power is 16, obviously x to the 4th power is just x to the 4th power. Now I'm going to bring down that 4, but 2x to the 3rd power is 8x to the 3rd power. I'm bringing down that 6. If I square 2x, I get 4x squared. Now this negative 1 has an exponent as well. If you square a negative, it becomes positive. So I will have a positive 1 now. Alright, there's my 4. This 2x has no exponent. But the negative 1 to the 3rd power becomes simply negative 1. If you raise a negative number to an odd power, the negative stays. and 1 to the third power is just 1. So we have a negative 1. And negative 1 to the fourth power becomes positive 1. So I have applied all of the exponents. Now we can simplify further and get the final answer. The first term will be 16x to the fourth power. For the second term, 8 times 4 is 32. But don't forget this negative 1. Multiplying there, we get negative 32x to the third power. Next, we have 6 times 4, which is 24, x squared. And this one stays positive. And you can probably see that we are alternating signs now. So I had positive, negative, positive. So sure enough, the next one is going to be negative 8x. And then plus 1. So this is the expanded binomial. Again, if you wanted to skip this orange step, that means you're going to do something like this. 2 to the third power is 8. 8 times 4 is 32. And then the negative 1 makes it a negative 32. Example 12. What is the coefficient of the term containing x to the fourth power when the expression x plus 5 to the sixth power is expanded? The degree 6 tells us to look at this row of Pascal's triangle, and here are the coefficients. The x is on the left, so I start off with x to the sixth power on the left. And then it goes x to the fifth power, x to the fourth power. This is the term that we want. And then it would go on from there. I don't even need to write the rest because this is the term that I need. The 5 is on the right, so I start off with 5 to the sixth power on the right. And then it's going to go 5 to the fifth power, 5 to the fourth power, 5 to the third power, and 5 squared. We want the coefficient of this term, so we need to just figure out what 25 times 15 is. So there are lots of ways to do it, but when I do 25 times 15, I would do 25 times 10 plus 5. I find this to be very easy. Doing the distributive property, 25 times 10 is 250, and then 25 times 5 is 125. Adding these together, we get 375. So that is the coefficient of the term containing x to the fourth power. When I did example 12 just now, I showed more work than I needed to for instructional purposes. When you do it, it'll look a little bit more like this. You know that we are looking at this row because of the degree 6. Because we are looking for the term containing x to the fourth power, we know that the x is on the left, so as we start counting from the left, the 1 is going to be x to the sixth power, then x to the fifth power, x to the fourth power. So we know we're talking about the 15. So you would just write down the 15 without the rest of the blue numbers. And then we would go for the rest of the coefficient, starting with the 5. The 5 is on the right, so you will start counting from the right. And you would know that this 5 would be 5 to the sixth power, and then 5 to the fifth power, 5 to the fourth power, 5 to the third power, and then 5 squared. So then you would just say, x to the fourth power times 5 squared. So you can get right to here without showing all of this other stuff. And then you would do 15 times 25 and get your 375. So you do not need to show all of this work. Let's do example 13 without showing so much work. What is the coefficient of the term containing x to the third power when the expression x minus 3 to the eighth power is expanded? Looks like I need to add one more row to my triangle. Here's one more row for a plus b to the eighth power. Again, I got these numbers by adding 1 and 7 to make 8. 7 plus 21 makes 28, and so on. So which one of these numbers will lead to the coefficient of the term containing x to the third power? We start off with x to the 8th power, and then x to the 7th power, 6th power, 5th, 4th, 3rd. So we should be staring at the 56. So far we have 56x to the third power, but now this is going to be multiplied by negative 3 to some power. What will be the power? This one starts off from the right at negative 3 to the 8th power. Then it goes negative 3 to the 7th power, 6th power, 5th power. So I need to do negative 3 to the 5th power. Raising a negative number to an odd power keeps the negative. So I know my final answer is going to have a negative in the front of it. So ignoring that for now, 3 to the 5th power is 3 times 3 times 3 times 3 times 3. So if I need to do this without a calculator, I might do something like this. 3 times 3 is 9. 3 times 3 is another 9. So it's really 9 times 9 times 3. Of course, 9 times 9 is 81. So it's just a matter of what is 81 times 3. 3 times 81 is 3 times 80 plus 1. 3 times 8 is 24, so I know 3 times 80 is 240. So that's 240 plus 3, that's 243. So that is 3 to the 5th power. So the coefficient we are looking for will be negative whatever 56 times 243 is. I don't know a shortcut for that, and I'm not going to bore you by demonstrating the algorithm for 243 times 56. I trust that you can do that on your own. The coefficient of the term containing x to the third power is negative 13,608. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.